Well, we're at gotomath.com working on a new section, and that would be we're going to be talking about differentiation. And this section here is going to be all about finding the derivative by the definition. So finding the derivative, and of course this is what you're going to see when you click that. But let's go ahead and go over to the whiteboard and sketch something out. No, we'll sketch something out. So the definition of the derivative, I'm going to go ahead and just write up what that is. We got f prime. Now that's not a 1, that's a single quote, you should say, if you were to find it on the keyboard. Now if you're seeing this for the first time, it's okay. Don't be afraid. And this is the limit of delta x approaches 0 of f of x plus delta x. Just write all this down. It'll eventually click if you go through and work some of the problems. And this is all over delta x. Now this is called f prime of x, and this is the actual, this will be the derivative of f of x, just regular f of x. Now it's a prime right there, not a 1. Okay, f prime of x exists, right, as long as the limit here exists. So this is the definition, as long as the limit exists. So the limit must exist equal to some real number here. Now what is this? Well, I'll just tell you. It actually comes kind of from here. If we were to let m be the slope of a line and we had 2 points, for example, we had the point x of 1 and y of 1 and x of 2 and y of 2. Okay, so we have 2 points and we want to find the slope of the line that passes through these 2 points. Well, that slope, remember, formula is y2 minus y1 over x of 2 minus x of 1. So you see this right here? That's all that this is. It's the f of x's, right, or your y values, and then down here, of course, something got simplified, but this delta x really kind of represents these guys right here, the change in x. But that's all that this is. This is the slope of a line, and that's what the derivative geometrically represents, the slope of the tangent line at a point on the curve. And I think probably at this point in time maybe we should draw a curve. So let's draw a curve here, and let's identify a point on the curve. We want to keep using different colors, I guess. Okay, so I'm going to pick a point right there, and let's pick, we'll pick this point. We'll pick a point right here. I don't know, let's pick this point. And if I drew a line, which I'm going to attempt to do, I'm going to try to draw a straight line. Oh my gosh, it's tough to do on this thing I'm drawing on. Okay, so that's supposed to be a straight line. Now this line right here is called the secant line, and I'm probably going to run out of room here. Secant, this is known as the secant line. This line that passes through 2 points on this curve right here is known as the secant line, and I should probably state this curve is f of x. Okay, this is the graph of f of x right here. Now let's go back here. So this is the secant line, and you know what? I should also, let's draw let's draw an x and a y axis here. Okay, let's do that. Okay, and I'm going to erase this because this is going to end up getting in the way. Okay, what happened to my pencil? It's disappeared. There it is. All right. So this line right here is known as the secant line. And let's identify these 2 points right here on the line. So we're going to let this point right here. So this will be x, okay? And then the y value associated with this line, we'll just call it f of x. Okay, we'll just call this point f of x. This represents our y. And I'm going to come down here and write that ordered pair. So we have x and f of x. Okay, so that's the ordered pair. That's this line. This is the address, I guess you could say, of this point on this line. Now this point, okay, this point is going to end up being, now let's say we take this distance from here to here, and we're going to call that distance delta x. Okay, this distance from here to here, we're going to call it delta x. And then, so it's going to be this number here plus, and then the distance from here to here. So we're adding this distance plus this distance here. And we're going to call that x delta x. Okay, you got that? That's going to be the x, this part of the ordered pair. All right. And of course, this guy, the y value associated with this will be, I'm going to end up running out of room here. Okay, this will be x, I was getting ahead of myself. The y value is f of x plus delta x. All right, that's would be the y value. Okay, somewhere over here is f of x plus delta x. Okay, that's the y value associated with that. So that ordered pair is going to end up being x plus delta x, comma, f of x plus delta x. So now we have 2 ordered pairs, okay? Just like up here we have 2 ordered pairs. You see this? And all we want to do is come up with this here. And I guess I should have done put my m more there, okay? All right. So we have the two ordered pairs, and we want to find the slope of the secant line. Find the slope of the secant line. Well, you need to take a look at this up here because this is where we're heading. And so let's do that. We'll go ahead and use green again. Maybe I'll lighten it up a little bit. Alright, so let's construct this here. So if I have the 2 ordered pairs, then we just simply take, this is y2 minus y1, right? So let's do that. We'll just do that right over here. So we have f of x plus delta x minus, right? This would be our y1, f of x, and then that's all over our, now we do the bottom part, so this would be x2, so this guy right here, x plus delta x minus, and then this x right here, right? This would be our x of 1, as you can see. Alright, so this represents the slope of the secant line. That's what this represents right here. You could say m secant, the slope of the secant line. Now, of course, as you can see, we can actually simplify this. We could simplify this down by crossing these x's canceling out, and what are we left with? We're left with a delta x. We're left with a delta x on bottom, and we'll go ahead and actually do that. Rewrite this thing. So we have f of x plus delta x minus f of x, and it's all over delta x. There you go. So we have the formula here for finding the slope of the secant line. So what's going on here? We're taking the limit as delta x approaches 0. What exactly does that mean? Well, it's pretty simple, actually. If we let delta x go to 0, in other words, this distance from here to here is going to get smaller and smaller and smaller, all right? And it's going to get smaller, 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 smaller. And what's happening to this secant line right here? If this point, okay, this point here is staying fixed, it's not moving, but this point is moving. So the point is moving along. For example, we'll make a jump here. We'll put the point right here. Okay, put the point right there. And so what is going to happen is, all right, let's draw a new secant line. Okay, so here's a new secant line, right? And what has happened is, so we have a new x plus delta x. Of course, this delta x has gotten smaller now. Okay, it's getting smaller and smaller. Well, as we move this point along and we draw a new secant line, if I can do this. So what's happening as we get closer and closer and closer and we approach, delta x approaches 0. Okay, so this is x plus delta x here, x plus delta x. Okay, it's getting smaller and smaller. What's happening is the secant line is converging towards what's called the tangent line. So this will become, as delta x approaches 0, in other words, gets extremely, extremely close there, but never reaches x. What happens, and I'm going to go ahead and make this in red, we'll call this the tangent line. And so it converges towards the, see if I can draw this, converges towards becoming the tangent line. You see that right there? Okay. And this geometrically represents, the slope of this line right here is going to represent the derivative when we evaluate it at some x value. So this would be the x value right here. Let's say it was 5 or something like that. We'd probably f prime of 5. That would actually represent the slope of this line. The slope of this line. Okay? And so if we're going to let delta x approach 0, then we're going to use the limit. We're going to use the limit to do that. And of course, you're going to see this demonstrated in problem 2, 3, 4, 5, and so on, where we're going to be doing this. But this is the explanation on what the heck this thing is. So remember, this represents when we put a number in here and go f prime of 5 or 3 or 6 or whatever it is, this will represent the slope of this red line right here. You see this right here? Now this particular red line, but actually it will be good for any point on here, any tangent line, right? So here's a very special place right here. The slope of the tangent line at this particular point, the slope of the tangent line is 0. Slope of the tangent line 0. That's going to be extremely important, especially when we want to find the minimum. And then there's the maximum, right? The slope of the tangent line here is going to be 0, going to be 0. So these are very special places here on this particular curve. But hopefully you understood that, and just go through and work problems 2, 3, 4, 5, and so forth, and where we actually use some numbers and so forth. Okay? So that's my explanation on the definition of the derivative. All right, and I will see you here. Okay, bye.